This is Team CEWI Cumber, and we are presenting our autonomous robotic flagger system. Our team is composed of Connor, Emmanuel, William, and Isa. Construction flaggers face serious safety risks every day. Our solution is an autonomous robotic system that takes over these tasks, boosting safety, cutting costs, and increasing overall efficiency.
Construction sites frequently expose human flaggers to life-threatening risks while performing simple traffic control tasks. Current alternatives lack flexibility and cost efficiency, creating a gap in the market for a mobile, programmable robotic flagger that can operate safely and autonomously within existing construction workflows. Okay, to achieve this, my team is proposing 4 robot types: a traffic counter, flagger, crosswalk guard, and a control unit.
Here we have the four-wheel high-visibility flagger bot with an ultrasonic sensor to avoid collisions, a safety light for extra visibility, and an 8-foot-tall slow-stop paddle that is designed to flow traffic via the control bot instructions.
The traffic counter robot is a series of modular units placed throughout the traffic instruction zone. They utilize a passive infrared sensor to detect the motion of the vehicles passing by. The unit itself houses an internal counter that counts the amount of vehicles traveling throughout the construction zone. This number of vehicles is allotted by operators by the control bot. It also houses an internal antenna that sends signals to the control robot.
This is our Crosswalk Guard bot, a semi-autonomous robot designed to protect pedestrians in construction zones using ultrasonic sensors and camera eyes. It detects when someone is approaching. It then activates red LEDs, raises 12-foot barrier arms to stop cars, and plays audio instructions through a speaker.
And to me was a control unit robot, the leader of the bunch. Accessible to project managers, its job is to oversee the other robots and give commands to them. My robot, in compliance with MUTCD guidelines, will be equipped with HDPE panels, which will give the robot weatherproofing capabilities. The robot stands 7 feet tall, allowing other drivers to see the robot on the road, in addition to its reflective tape, which reflects lights from cars' headlights, allowing for increased visibility. The control unit robot will send out a signal to the other robots, specifically the traffic counter. Once the traffic counter received its information, it'll go back and forth transmitting information. The control unit will give that information to both the flagger and the crosswalk guard to achieve their jobs accordingly.
Here you can see the robot collaboration algorithm. We'll go over each step in the next slide by animation. Here are all robots working together in a construction zone. First, the operator turns on the control bot. Then the robots are all turned on via the control bot operation. Next, the flagger bot and crosswalk bot display the stop signal, and then the traffic counter bot begins to count. The traffic counter bot alerts the control bot to traffic needs, and the control bot alerts flagger bot to display slow. Next, the traffic passes through. You can see the counter bot counting the traffic as it goes. And once there's no more traffic, it resets to 0 to let the system know. Next, the crosswalk bot alerts the control bot of pedestrians. The control bot then alerts the flagger bot to display stop. And the crosswalk bot allows pedestrians to cross. Finally, the crosswalk bot alerts control bot of pedestrians clear, and the control bot alerts flagger bot to display slow, allowing traffic to continue.
When we consider benchmarking and the value added with our system, we know that current methods of control within traffic construction sites are bulky, expensive, and they're non-autonomous. They rely very heavily on human interaction. Our systems and sensors are more mobile, scalable, and cost-effective. And they greatly reduce the risk of human injury or even death. Our total systems cost around $15,000, while the current methods in place cost around $50,000. In conclusion, our robot not only meets the MUTC standards, but is also more safer than the current human methods in place. Compared to the alternatives, it is cheaper, safer, more adaptable, and more mobile. The lessons learned here is that collaboration is key. With the current human methods, communication may get lost throughout the construction site zone. However, with our system, communication is crucial and integrated within all components of our system.